In this lesson we will conduct a load flow analysis in Etap. So I have the single line diagram already open on the Etap window. So in order to conduct a load flow analysis, I will have to hover over to this mode toolbar over here and select the load flow analysis mode. After selecting the load flow analysis mode, on the right side I have this option called run load flow. So after clicking on it, it will ask for an output file name. Enter in a file name and click on OK. So now we have some values alongside our single line diagram over here, and also we have some percentages displayed alongside our bus. So in order to understand what these are, I will go over to this unit show on my right side and click on it. And here we have the units of the displayed numbers, which are kilowatts and kVArs. So now we have the total power drawn from all the sources over here. That is, from the grid we are drawing about 5 megawatts of power, and from the generator I am drawing about 1 megawatt of power. And these percentages are used to represent the percentage voltages at each buses. So in order to understand much better, I will go over to the display options over here, and we can change the display options from here. So the bus voltages are presently at percentage voltages. So if I change this over here, these become kilovolts. So this is 110 kilovolt, and over here we have 109.9 kilovolt, and similarly all the bus voltages are displayed alongside their buses. And let us view these in amps. So let me go to the display options over here, and I will change this to amp, and I will click on OK. So I am drawing about 26 amps from the grid, and over here I am drawing about 140 amps from the generator. And next thing I will have to look is the alert view over here. If we have anything faulty in our single line diagram, mainly referring to the oversizing or undersizing, because of that we will have overloading or underloading. Etap doesn't show you if anything is underloaded, but it will show you if the system is overloaded or if the generator is underexcited or overexcited. So let me go over here and see if we have any alerts over here. So clicking on the alert view, and on the alert view I have two windows, which is the critical and marginal over here. Presently we do not have any problem with any of our devices, so it is clean. Let me close this over here, and over here we have the ampere loads, which are drawn by the two lump loads over here, which is 2 megawatts and 3 megawatts each. And next thing I will have to show you is the report generator. I can select the load flow report from here and click on the report manager, and this gives me the study case and load flow report for the study case. So maximizing this, I have the voltages and phase angles, the generation at each bus, and the load connected to each bus, and this will show the load flow through all the buses. So let me close this. And next thing which I want to show you is this over here, which shows the load terminal voltages, and after clicking on this I have the load terminal voltages displayed over here. So I have 11 kV and also 11 kV terminal voltages at the loads. So let me turn this off, and here we have the line and cable voltage drop, and after selecting this I have 0.067. So let me change the display units over here. I will change it to percentage and click on OK. So I have about 0.1 percentage change. I mean 0.1 voltage drop. Over here I have 100% and over here I have 99%. So we have a voltage drop of about 0.1 percentage. And here we have the load flow result analyzer. We can use this to analyze our reports. So I will click on the general info, and here we have the study case. All the study case that I have created using this will be displayed over here. So presently we are in this study case, and we have the loading categories. So everything is loaded, every load is put in design mode. So the diversity factor and so on. If I want, I can change the loading category. For that I will have to double click on this, and on the nameplate I will have to change this over here. So I have only put the values for design and normal. If I want, I can put values in here as well and change the loading categories from the load analyzer over here. So if we want to change the type of load or the diversity factor, then I will have to go to this option over here, which is called the load analyzer. And next thing I want to show you is the edit study case over here. So hovering onto the presentation toolbar and clicking on the edit study case, the load flow study case option appears over here, and from here too we can change the rated voltage units and power in MVAs to kVA and so on. So here we also have the method for load flow studies. So at present it is at adaptive Newton-Raphson method, and the precision is 0.0001. So the maximum iteration is 99, and this is the precision value, that is 0.001. If I want to change the precision I can, but this is pretty good for me. And from here I can also use the loading, I can also choose the loading category which I mentioned before, and over here we can change the conditions over here, that is for critical values and marginal values. So about 95 to 100% is the loading the percentage voltage for the bus, and if anything is shown below 95%, it already puts it in the critical mode. So I can change these options over here and stop the alert manager from notifying me. And this is how you conduct a load flow study in Etap.